Anirudh Sharma, founder and CEO of Digantara. Mr. Maximilian Leroux, head of partnerships, Aurora, Propulsion Technologies, and Dr. Agnes, co-founder of Re-CAE. Also, very quickly, I have to just take a minute. Just a reminder of the startup mixer that's happening up at the level 1 above at the Regal Hall. We started 2:30, it might have been started by now. So all the startups and entrepreneurs, mentors, investors can kindly proceed to the Regal Hall as at 2:30 we started the startup mixer. Also in the continuity, day 3, which is tomorrow, there is one important session and we'd like to remind you on that. It's Explore India, Italy Joint Space Ventures and Italy's advancement with ASI and ISRO collaboration, research and development and upcoming mission launches will discover the forefront of Italian research in space. And for the same, we have again Professor Teodoro Valente, the President of ASI, joining in the session in hall number 4, along with Mr. Sergio Lega, Scientific Attaché Embassy of Italy, Ms. Antonietta Baccanari, Trade Commissioner, Director of Trade Promotion Section of Italian Embassy in New Delhi, Coordinator for India, Bangladesh and Sri Lanka, Mr. Roberto, Managing Director of Leonardo Aerospace Defense and Security India, Mr. Roberto Simonetti, Chief Representative Officer India ELT Group, and Mr. Francesco Mori, Space Secretary ELT Group. So that's a session which will be conducted tomorrow in the hall of the Regal Hall at 1:30. So over to you, Chair.
Thank you. The Wi-Fi is working here, so this makes me bold enough to actually go live into our system. But good afternoon, I'm Air Commodore retired Terry Haren. I am the President and Managing Director of Leo Labs in Australia, which is a subsidiary of Leo Labs in the United States. My third trip to the India Space Congress, and I've met many wonderful people here in these trips, including my special friend Venkat down the bottom here, who's going to be asking a lot of hard questions later in this presentation. I'm joined by an esteemed international panel with people from the United States, from Finland, Sweden, Japan, and of course host country India. And we'll look at a very important issue of space sustainability, with our theme today being ensuring a sustainable space future with space exploration. But with moderator's privilege here, I will make an introduction about some of the sustainability issues that we are seeing in Earth's orbits. And this, in fact, is the visualization of the Leo Labs system. If you are not familiar with Leo Labs, we operate 10 ground-based radars, and you can see 4 of those in this visualization, including radar south of Perth there in Australia, which is what we call West Australia Space Radar. We are tracking all the objects in low Earth orbit. Today we're tracking 22,000 resident space objects and updating their orbits routinely with precision to basically provide information for space traffic management purposes. So this picture shows you that low Earth orbit, in fact all the orbits, but low Earth orbit in particular is congested. The number of satellites operating now in low Earth orbit has doubled every year. It's in the order of 9,000 satellites. And in 2018, so just over 5 years ago, it was 800. So we've got a 10x increase in the number of satellites operating in low Earth orbit. We think that will double every year by the end of the decade. It's really how long is a piece of string as to how many satellites are operating. There was a session before lunch about mega constellations, and that's what's going to happen on live presentations going down. But there's currently 6,000 Starlink satellites in low Earth orbit. When I came here 3 years ago, there was 2,000. So if we look at Starlink, it's obviously leading the growth of the congested space issue in low Earth orbit. So with that comes, the increase of the risk of collisions and conjunctions against other satellites with space junk and debris. Now that would be all good if low Earth orbit wasn't already inhabited by a huge debris field. We'd have 10,000 objects being tracked today in low Earth orbit. And that would be still a significant consideration, but the other problem we have is lots of junk. Derelict objects. This is 1,000 rocket bodies that are floating around the Earth. So this is the problem. Space is getting congested. And with congestion, it's just like the roads here in Delhi. The risk of collisions, the risk of further degradation of the environment is a real issue. Just to show you quickly what we do, I won't get into that. And this will take some time to load up. But what we're doing is calculating the orbits. In fact, we do a calculation every second. We'll update if you like, and then 300 conjunctions, and then we work out the conjunction of every object in the catalogue and provide that to our customers. And what I thought was, just a quick example, we're seeing a critical conjunction every couple of weeks. And this is one that's actually scheduled for tomorrow at 16:04 Zulu, if you really want to know. It's one of those rocket bodies, an SL-16 rocket body. An SL-16 rocket body was probably launched in 1980 to 1990, so a derelict Russian rocket body. It weighs 8,000 kilograms. It's about the size of a bus, and it's no one's flying it. And it's going to have a conjunction against some NOAA debris. Calculations at the moment say 122 metres wide in 1,000 chance of collision. So this is something we're watching, an example of the routine risks occurring on a daily basis. Last but not least, if you do follow Lear Labs on LinkedIn or Twitter. This morning, one of our analysts picked up with one of the radar classes a breakup. So this is off the press. Between 13:05 yesterday Zulu time and early this morning 0051, we went from tracking one object, which was called the Regius P1, to now it looks like there are at least 16 objects in that same orbital plane, which means there's been a fragmentation event with that satellite. We'll let the analytics run from there, but this again is an example of the other issue, which is contested space operations. So we'll let that play out, but these are the two big issues when we talk about in sustainability terms. Okay, enough from me. And thanks for the display there. I'm going to sit down, but I thought today we'd talk about sustainability in three broad areas. First, about policy and the regulation, about stopping the build-up of space junk in debris. So looking at sustainability from prevention in some respects, and then we'll go into operating in this environment, and finally into debris mitigation. So I'm just going to move. So yes, the first policy issue we want to talk about is basically preventing the build-up of space junk and debris. So my first speaker this morning comes all the way from Washington DC. Victoria, Samson from the Secure World Foundation, and in fact we work very closely with the Secure World Foundation. We really lead some of the policy and regulations sort of debate at Washington. So welcome, Victoria.
Thanks, Terry, and thank you for seeing me and inviting me. Hello, everyone. My name is Victoria Samson. I'm the Chief Director of Space Security and Stability or a nonprofit based in the United States called the Secure World Foundation. The Secure World Foundation focuses on long-term sustainable use of outer space, promote best practices and norms of behavior to make sure that space is accessible to and usable for all long term. So I'll be talking about three main things here in the minutes that allowed. We have a good panel and we'll get to hear from the other panelists. The first thing is just talking about the disruptive nature of the very much constellation we had and the sustainability of the space environment. Second, I'll be talking about security and stability of outer space issues. And then third, talking about geopolitical issues, relocating to the moon. So, just a little bit, just contextualize, as Terry said earlier, right now there's about 10,250 active satellites in orbit. And just to get a sense of how many each individual actor is, Russia has 280 active satellites, India has 68 active satellites, China has 879 active satellites, the United States has almost 7,200 active satellites, so some of big difference. But of the United States active satellites, over 6,100 are Starlink. So what we have is of the 10,000 active satellites, we have 6,000, so about over 2/3 are from one individual player. And that individual player is not a nation state specifically, it's a commercial actor. And so that's a huge disruption in terms of how the governance mechanisms have been created for space. I know it kind of rolls our eyes and get, the governance mechanism, why does that matter? I mean, space is a shared domain. When we have issues of shared domain, you talk about the nation states. And that's how the international system's been set up to deal with these sort of issues. And yet we have a major player who is shaping the space environment, who's setting a lot of the norms, not in a bad way, but setting a lot of the norms. And there's no way to incorporate them into national discussions. So it's a huge thing to think about for the future. And in terms of issues for looking at the future for governance issues, as we've talked about before with the negative constellation issue, one of the things to look about is, they're affecting possibly the Earth environment, both in going up and coming back down. The amount of satellites being launched, the exhaust from the rocket launches could very possibly have an effect on the Earth environment. We're not sure. The models did not anticipate this level of rocket launch, and so if we want to account for it, it could be changing things as well. The amount of debris that's coming back down, right now our responsible space actor has an end-of-life plan for the satellite, and for most actors that means bringing it back down to burn up in the Earth's atmosphere. Which again, back in the day, that was fine, but as we look at the sheer number of these satellites coming back down, they actually may be adding aluminum oxide to Earth's atmosphere, which may have an effect on us in the air, which may have bad effects for us on the ground. So again, this isn't certain, but it's one of those things where it could have issues for the future as well. It's a challenge for spectrum allocation. I know we talk about space. We often focus on the physical congestion, but spectrum is a very serious concern. There's concern for space traffic management issues. There's concern just for monitoring for SSA and debris. And then just the idea of, if we have 10,000, or, we're looking at these very large constellations. I mean, not all the configuration right now, we're only talking about Starlink, but as we heard in the panel earlier, we're looking at hundreds of thousands of constellations. We have Starlink, we have OneWeb, you have Amazon, you have the Chinese have 3 different constellations we're looking at, the Germans have constellations we're looking at. Rwanda has a huge constellation we're supposedly doing. Not all configuration, but probably a significant percentage of them will. And so when you're looking at that, you have thousands and thousands and thousands of satellites in one Earth orbit. Do you have to worry about the carrying capacity? Will that orbit get fall for purposes full? Maybe, maybe not. We don't know, but these are just things we need to think about as well. But I also don't want to say that these are bad things. I mean, I will say, for example, these very large constellations, they have very short lifetimes, which means they come back down. Their end-of-life plans are a lot shorter than what's considered the international normal responsible behavior, which is 25 years of mission. Most of them are several years, possibly even short as 1 year. And so that's setting a new norm for that. As well, some of them are establishing right-of-way principles. Before space is big, you didn't have to worry about other constellations and the satellites. But now as you have more actors getting in orbit, you need to figure out, hey, how do we do? If 2 satellites during close approach and both maneuver, how do you decide which one moves? And so, for example, Starlink has signed an MOU with NASA saying that when it comes to weather size versus NASA is right away. So, and these are important distinctions to start thinking about. And then finally, big picture. I think oftentimes these very large constellations are criticized for the effects of having the space environment, that's something I don't want to downplay that. But, in the grand scheme of things, they are doing things to help out on local humanity in terms of bringing satellite internet connectivity to parts of the world that didn't have it before and will not happen. So just thinking about big picture discussions. Moving on to looking at counterspace. As we have an increased number of countries and actors that are dependent on space capabilities, there's an increased incentive to deliberately interfere, disrupt, deny, or in some way degrade those access to reuse of space capabilities. My organization, the Secure World Foundation, puts out a global counterspace threat assessment where we look at unclassified open source information about counterspace capabilities around the world. The reason why we started doing that, we started in 2018. The reason why we started doing that is because counterspace discussions get classified very quickly. And so we're trying to figure out, okay, what's actually happening. Here in the West, you read a news article about a Russian or Chinese test, and you either get hyperbolic discussion, or it just be like, well, it's classified, we can't say that we only knew. And so we said, okay, how much can you actually find out about these sort of things? As it turns out, there's quite a lot of information out there. I have a few copies available with me that's available for free on our website. It's in English, but the executive summary has been translated into all 61 languages, and this year Japanese and Portuguese. And kind of the big picture sort of thing is there are a lot of countries that are doing a massive amount of research and development, and even operationalizing some counterspace capabilities. But there's different levels of counterspace capabilities. There's counterspace capabilities that are destructive, that are non-destructive. There's counterspace capabilities that are reversible, that are temporary, that are permanent, and reversible. And so if we're looking at active military conflicts, the only counterspace capabilities that are currently being used are those that are reversible, temporary, and non-destructive in nature. I'm happy to talk more about that during the Q&A. But I will point out in our counterspace report, we look at 12 different countries, including the United States, including India, just to get a big picture of the overall concerns that we have about space capabilities. And so there are various efforts, ways in which to deal with counterspace threats, not just military hardware. There are diplomatic efforts that happen in the United Nations and other discussions, looking at how do you establish those norms behavior, how do you establish patterns of life, so you can see when things are different. As well, there's the idea that there's actions that individual countries can do. In April 2022, the United States, partially in response to Russia's November 2021 anti-satellite test, which created 1,800 pieces of tracking debris, of which almost 70 are still around at this point. In April 2022, the United States made an announcement that it was committing not to conduct destructive anti-satellite missile tests, which is very wordy, but it's worded very specifically for a reason. And part of the reason was they say, okay, those kind of tests that would happen, they create a large amount of debris in orbit, and even though Astroscale is doing their best, we're still not at the point where we can remove debris. I don't think any actor or any company is saying, okay, we're going to build the capability of 100,000 pieces of debris should happen. And so, as we know, that threatens actors in space. You can be an ally to the country that's doing these ASAT tests. But due to the sheer physics of the space environment, if you're running into that piece of space debris, it's going to threaten your asset as much as if you were a rival. And so the United States made this commitment not to conduct destructive anti-satellite missile tests. And over 36 countries have joined the United States on this. As well, there was a UN resolution in support of this in December 2022, where 155 countries voted in support of it, 9 voted against, 9 abstained, and India was one of those countries that abstained. My organization, the Secure World Foundation, wanted to put together, to indicate that there is interest in multiple sectors on security and stability of the space domain. And so one of the things we wanted to point out is that the commercial sector has a huge investment, quite literally, in the space domain being a stable and predictable space environment. And things like these destructive anti-satellite tests that create large amounts of debris in orbit, they affect the commercial sector. The Russian anti-satellite test in November 2021 created a large amount of close approaches called conjunctive squalls, where essentially the debris from that test was doing uncoordinated close approaches, interfering with pretty much every single remote sensing satellite in a sensing group's orbit for the next year or so. And so it's a huge factor for this. So we said, okay, we have an industry statement of support saying, okay, we the commercial actors in the space sector think these sort of tests are so destabilizing and so threatening that we want to support the idea that countries are making these unilateral commitments not to conduct these tests, and we encourage more countries to do that. When Secure World released that statement in November last year, we had 26 companies, including 2 on this panel, Digantara and Astroscale, that made this commitment as part of destructive anti-satellite tests. So 26 companies from 10 countries. Right now, we have 49 companies from 14 countries, and I would encourage any company sitting in this room, if you are concerned about the space environment, if you are concerned about debris being created that can actually destroy your assets and make your business case a lot more challenging, more expensive to operate orbit, this might be something that you could do as an actor to indicate that you are trying to support a sustainable, predictable space environment. With that, I think I've actually got my time, so I will knock it off now and then look forward to hearing from the other panelists. Thank you very much.
Thank you, Victoria. And I thought Skill Foundation's important role in providing information for policy and regulators, especially in the United States. They're not for profit, so they very much lead the sustainability debate in the US. So thanks for laying out all the concerns, of which there's many, and they all layer up as I sort of indicated. I'm going to ask actually Dr. Agnes Chan, who's the co-founder of Re-CAE, who's going to probably put a different perspective on this from modelling and software in terms of modelling the debris issues and software to manage some of those issues. Agnes.
Thanks, Gary. And thank you, Victoria, for laying the ground and giving all these insights. I think it's really important that we start raising awareness today, and space debris issue is definitely a global issue. So my name is Agnes, I'm co-founder and CEO of Re-CAE, a startup based in Switzerland, and our goal is to bring in automation tool to help make space operations more efficient, with the primary goal of building a space situational awareness for space operators. So to introduce the software suite that we are working on, I will be dividing the type of software that we develop into 3 main categories. So the first one will be for mission planning. The second type of software will be for during space operations itself. And the third category will be for end-of-life management that I think is lacking a bit of attention, because space sustainability is not just about protecting space, but also Earth infrastructure for when post-mission disposal happens and satellites being used. So as Terry mentioned, Re-CAE is a software-focused company. For the first category, if I get back to mission planning, Re-CAE focuses on space debris modeling. I am going to give 2 concrete examples to make things clear and frank. So for the first application, for example, is space-based solar power. Nowadays, the idea of space-based solar power is to build thin layers of solar panels in space, and they are going to take up a lot of space in lower orbit. So what we do is we can model the directions and the quantity of space debris around these solar panels to make sure that they are built the right way and what happens if they come into collision. So this part is mainly focused for pre-design and mission planning. The second example that I would love to share is for deorbiting devices such as drag cells, and we are working with a German-based company that works on drag cells, a passive deorbiting component, and I think it's one of the most effective ways for post-mission disposal to accelerate the deorbiting of satellites. And we work closely with companies like that to make sure that the drag cell has the right dimension and the satellites do deorbit at the time when they mentioned. So these are the types of space debris modeling that we could do for mission planning before a certain mission is launched. And the next phase is definitely during space operations. And in this section, we focus mostly on flight dynamics analysis, where we include attitude, orbital propagation, conjunction analysis, up to 7-9 days ahead. Collision alerts, for example, we run special perturbations algorithm, and we also suggest to satellite operators the best maneuver to be done so that they do not get into collision with something else in the upcoming 3 to 4 days, for example. And lastly, I would like to highlight one of our core technology, I would say, our Re-CAE originated, which is the atmospheric re-entry prediction. So to give a little background of the company, my co-founder and I, we both worked for the French Department of Defense before, and we realized that there is this gap in commercial tools when it comes to high fidelity predictions, and especially for atmospheric re-entry predictions. So this is one of the main reasons why we launched Re-CAE. And we also think that the complexity of such predictions and simulations are currently underestimated. And I'm sure most of you had heard of it 2 days ago. This family from Florida who filed a lawsuit against NASA when a piece of the ISS battery pack hit their home. So here, what the message that I'm trying to convey is that if there is a software tool or prediction tool that is precise enough to at least predict the trajectory or the location or the ground impact of the re-entry of a certain object, such risk could be mitigated well before. So in Re-CAE, we did a technology transfer from our military background to the commercial background and try to bring into application this atmospheric re-entry predictions for a space debris mitigation application. So recently we ran a benchmark test with the European Space Agency where we ran a simulation for the Delta II upper stage. This is a real event that happened in 1996 where fragments were recovered around Texas, and someone was actually hit by a piece of debris from this rocket body, if I'm not mistaken. And with our simulation, we could come up with up to 100 fragmentation events and 15 body fragments that were found on Earth's surface by itself. And when we did the benchmark, our computation could restitute the exact coordinates of these recovered fragments that were found in Texas. So I think the message here is high fidelity simulations are one of the key components, I would say, for better mission planning and to make sure that no collisions happen in orbit, and also a better end-of-life management for space missions. And just to conclude, we have a bigger vision. So we will be using this existing software as the building block to build an automation layer for the application layer of space operations. And the idea here is to bring autonomous navigation to satellite and spacecraft so that operators could really focus their resources towards real mission objectives. So I think that's all for me. Yeah.
Okay, well, thank you, Dr. Chair. And it's great to see Switzerland here in force today. It's the Switzerland Day. So we're going to move on, and I'm going to then talk about the importance, or the speaker will talk about the importance of space situational awareness for the actual mitigation and management of these sort of issues. So now I'd like to introduce Mr. Anirudh Sharma. Mr. Sharma is the founder and CEO of Digantara.
Thanks for the introduction, Debbie. Just to introduce Digantara, we are a space situational awareness company based in Bangalore, India. We started this company in the year 2020, and it's been 4 years now that we've been focusing on providing solutions on space domain awareness and space situational awareness to different customers in this particular sector, be it defense, governments, regulators, commercial companies, and insurance companies. What we predominantly focus on is towards building the entire value chain for space domain awareness or space situational awareness, where we build from sensors to be able to track objects in space. So we predominantly focus on space-based sensors, and these are sensors that are capable of tracking objects up to centimeter size from space, and we also specialize in ground-based systems to complement our space-based systems. And I will just add on to some points that Victoria and Terry mentioned during the note about why this is important. We've heard about constellations and proliferated duality, that there are a lot of satellites right now active in space, and the amount of debris has just increased in the last couple of years due to multiple reasons, be it more launches and access to space has become much simpler. Right now, commercial companies are launching more and more satellites, but space was never a sector like that before. It was predominantly governments launching satellites and operating satellites. From governments to commercial, we've seen a transformation in the space industry. So this transformation has consequences, and as every sector grows, there is certain things that we have to improve on for building a better infrastructure. So what we focus on is building that infrastructure layer for space sustainability and space navigation, that is through space situational awareness service. So here, what is very important is there are multiple companies, governments working towards tracking objects in space, be it US, Russia, China, tracking satellites with their existing systems that were previously developed to track missiles. And then they doubled out the same system to track satellites in orbit. And these systems are now being used to track satellites, and we track around 40,000 objects every single day. That's part of the US catalog. And there is a need for increased amount of sensors to be able to maintain custody of an object. And maintaining custody of an object is very important for us to build a resilient catalog. A lot of commercial companies are focusing on developing services, be it radars, telescopes, passive RF systems, space-based systems. So what we are trying to do here is bringing all the data together and complementing the data with space-based information just to enhance the data sets that are already available today. From 30,000, 40,000 objects in the catalog to, let's say, going towards 100,000 should be the goal, because we need to understand every single activity in space so that it is crucial for the future of space operations. Right now we're already talking about commercial space flights, we're talking about human space flight missions. For all these activities, space situational awareness will be the most important layer for anything that you do in the space industry. And the last point that I would like to touch upon is the data processing sensor fusion capabilities. Not a single sensor can, not just one sensor, by building just one sensor cannot solve the entire problem of space situational awareness. There is a need for sensor fusion and data fusion, where you not only take in data from just one sensor type, but you have to ingest, you have to be able to ingest multiple data sources into your platform. And you can build data fusion and sensor fusion capabilities. And this will only enhance the maintenance of the object custody. That is very important for us to provide the analytics that any end user requires. Be it, again, for defense, it's totally a different use case. For commercial companies, they would like to focus more on space operations, satellite operations, from telemetry tracking to be able to, let's say, avoid collision, optimize maneuvers, maneuver designs. For all such activities, data fusion and sensor fusion is important, and that's something that we're focusing on currently. While our last couple of years' focus has mainly been towards the defense markets, we've been able to build systems that can provide intelligence to the defense organizations based on the adversary satellite movements, when the satellite changes its orbital position, when does it do maneuver, and these are certain services that we've been focusing on. Currently, we're trying to work more on the commercial side of our solutions, where we provide services on mission operations, mission planning, and for a satellite operator to be able to design a mission, where to launch this particular satellite and how do they operate and end of life, because that's very important at this point in time. The last part of it is insurance markets. This is a very interesting market. Unlike other segments, insurance in space industry is a bit tricky and difficult for insurance companies to underwrite risk for space space-based assets or satellites that you plan to launch, that's mainly because of the dynamics of space environment, and that is not aware at this point in time. We don't have a lot of data points around what's happening in space, the dynamics of space, because if one ASAT or any collision happens, there is a chain reaction that is more deplicated, that changes the equation. And this was one of the scenarios in the 2009 iridium and cosmos sensitive. At that point in time, what changed was the upgradation of the data in the SSA valuation. If you don't change, once a satellite has maneuvered in your SSA catalog, it's very difficult for you to predict anything that will happen in the future. And that's where data fusion and the software capabilities that the other speaker just told will become very important for space sustainability and space operations.
Thank you, Mr. Sharma. Okay, I didn't do this on purpose. We're actually talking on the right side of the panel first, on the left side, high left, very shooting. So we agree, we talk space situation awareness and the other custody and other type things. We're going to move more into the technology areas now. So I'd like to introduce Mr. Maximilian Leroux from Aurora Propulsion Systems from Finland, who's going to talk about some of the technologies that aid to sustainability in Earth's orbit. Maximilian.
Thank you very much. Yeah, my name is Maximilian Leroux. He just said I work for Aurora Propulsion Technologies in Finland. I've been living and working all around the world for the past 20 years, and by trade I'm actually an economist, so I'm not from in space. And we'll see this more and more happening as this industry is growing. There will be more people coming with transferable skills. There will be product managers and marketing people and all kinds of professions coming into space industry. And why is this important? Our mission is sustainable space economy, basically, as Aurora, because space industry is not just an industry like telecommunications or life sciences. It's an enabling technology, an enabling industry. 15% of the world's economy, with the global GDP, is depending on satellites. The next generation, the millennials, they could not imagine how it would be to use a map that's printed on paper to find your way. You're using Google Maps, and if your satellite isn't there, you don't know where you are. And then if you're going to a gas station to buy actually a map because your Google Maps doesn't work, maybe your credit card doesn't work because the safe payment system is down. And so we have emergency responses, navigation, weather forecasts, TV broadcasts, internet. There are so many things that we depend on space. And on Earth already, we're using twice the resources that we can actually, that the Earth has, that we're using up. So why it took us quite some time as humans to understand that we need to build a sustainable economy, we need carbon emission restrictions, and the same goes for space. Now we still have a chance to do it right. In Finland, we have a thing called every man's right. It allows anyone to go camp overnight anywhere you want. You can't own someone's property, but if you don't see a house, for example, and this someone's property, you can go and camp there. But there's a rule that you cannot cut wood to make fire, and you cannot leave your garbage behind. You have to leave it the way you came. And I think that's a very nice thing that we should apply in space as well. Two things. When you go up there, make sure you don't hit anyone, so you don't create the garbage. And when you're done with the mission, put things down. And it's important because A, we want to keep up our economy here on Earth, and B, the future missions will suffer if there's stuff lying around. We had in the year 2000, we sent 120 objects into space. Last year alone, it was 2,600 something. So as we heard from the it's growing. In the past 20 years, it grew by more than 2,000%. And more than 95% of that lies in between from 500 to 1,000, 400 to 1,000 kilometers. So it gets really crowded. There are initiatives. For example, in the European, Europe was introduced a European space law that will require collision avoidance, and they were also working on something like a space traffic control system. Just like with airlines, we need to know where the other plane is flying so we don't hit them. We need the same thing in space. But if I can't control my own spacecraft, then the space control system will not work. So this will also then lead to the requirement that anything you send up to space also has some kind of muster system, some kind of system that's connected to an active collision avoidance. Now, if you're having a satellite in space and you may hit someone in 2 days from now, you will get an email that is registered. Now, someone really has to read that email in the company. It's probably some kind of info ad or who knows what. So it may be that we don't even know that we've received a warning and we may hit somebody. So that's compared to what technologies we have on Earth with apps where you ding pop up and now get an email on a satellite may hit another one. Just a few months ago, there was an old NASA satellite that almost hit an old Soviet Union satellite, these giant things. They were flying around doing nothing anymore. They passed each other by 16 meters. If they had hit each other, it would have increased the amount of debris in space by 50%. And so the more things we send up, the more dangerous it is for space. And I think it's important that the space industry itself also talks more about the impact of space on everyday life, and to make it more of a political agenda, another thing that we just like to talk about in our own little industry here. So that the other thing is about how to make sure you bring your satellites down when you're done. Now in the US, the FCC will enact a new ruling. It starts on September 16th, where the deorbiting requirement will be coming down from 25 years to 5 years. And I really hope, also of course for our business model, because we're selling a very good electric cell for deorbiting, but for the reasons that I just mentioned here, that they will rigorously enforce these laws of collision avoidance and the removal or the removal of your satellites, so that I hope after September 16th there will be a lot of companies having these emails coming in their inbox, the flight has been cancelled because they did not have anything how to deorbit when they're done. And it could also happen that maybe you launch your next satellite on September 15th, but then it's stuck in customs somewhere and coming late for a week. But I'm really happy to see that the regulators are coming in. This is when there's no regulation, then it's the Wild West. Anyone can do whatever they want, and we've seen that in industries how carbon emissions are so long put out into the atmosphere until someone says stop. Otherwise, they will never stop. If they're voluntary announcements from big companies are usually not more than a press release. The enactment of such measures takes too long. So, and that's how I like to see it. Also, like we have a mission in the company. Of course, we're in here to make money. We're a commercial company, but I think we're following a good mission. We want to make the world a better place and use space for it. Thank you.
Thank you, Leroux. And we did a good representation from SpaceX and Starlink and any of these forums, but we support them with our digital work system, and they don't get emails, they get hard data, and their mission system automates the orders that they fly every day. Certainly is changing and demonstrating what is good practice. We're going to continue talking about technologies and mitigations to sustain space. And now I'd like to introduce, right next to me here on my left, Mr. Tushar, who's the co-founder and CEO of Q Space.
Yeah, thank you, Derek. So I'm Tushar from Manastu space, and we are building green propulsion system for satellites, then automotive collision avoidance system, and space services to ensure that the whole, or at least some part of the whole value chain of space sustainability. So we talk a lot about the problem that we are facing currently. So, and just let me give you the different perspective about how we see things happening going forward, especially if they say next 5 to 10 years. What is changing in next 5 to 10 years? So the interesting development that is happening is the Starship. So just to put some number in front of you, Falcon 9 has a capacity of payload around to low Earth orbit is around 20 to 25 tons per launch. Falcon Heavy is somewhere around 60 odd tons to low Earth orbit, and Starship Heavy payload capacity is somewhere between 150 tons. So 20, where is 22 tons, where is 150 tons. Directly around 6 to 7 x jump in one launch. Falcon 9, 100 launches were there last year. But imagine the Starship production also goes into that order because it is optimized for the production. That is the same point. Imagine the capacity it can build, and the cost is $2,500,000 per kg category. Is for SpaceX charges is somewhere around $5,000. Elon Musk is targeting $30 per kg. Even the single-digit number is what is paid. And rough estimate you consider $300 per kg to start with. So if Starship is going regularly, like what the Falcon 9 is after say 8 to 10 years, so maybe next 5 years the Falcon, the Starship reaches that level, the amount of mass that we will be putting into the space, just because the economics works out that way, and that will lead to the new business model. Satellites may be different, maybe differently. The rules, regulations will be completely different, and the economics will be completely different probably. And the challenges definitely in terms of sustainability will be in a whole another level. So how are we preparing for that in terms of the technology, the policy, and all the dynamics that the industry will be saying, and of course the prevention of not getting to the worst of what in terms of the debris, and every satellite is facing some or the other challenges maybe in 10 years, reaching that worst case. So I'll just leave it with you with that thought in terms of sustainability, and why today acting today is so important. But even acting today may not be completely sufficient, but it is a very important start because the dynamics is going to change whole new way in next 5 years. That's what we think. Thank you.
Thank you, Mr. Jadhav. So, continuing now talking about debris mitigation and debris removal, and my great pleasure now to introduce Ms. Iwamoto from Astroscale, and in fact, I'll just mention, we supported Astroscale quite recently on your debris removal testing, so congratulations on that outcome.
Thank you, Terry, for the introduction. Thank you for organizer for inviting me to a very interesting, important discussion today. My name is Iwamoto. I'm from Astroscale, Japan. And if you're not familiar with my company, Astroscale is headquartered in Japan. We are 11 years old now. We have footprints in UK, US, France recently, and Japan. I belong to a Japanese subsidiary of Japan, Astroscale. So, what I would like to do today is to share with you a little recent developments on both mitigation, space debris mitigation, and remediation efforts, focusing on our latest mission called Astroscale mission. So please bear with me with a little bit of the space debris mitigation trend. And as you know, that the international community has been trying to address the issue of space debris through so-called international and global space debris mitigation guidelines, the SIA-INDIA guidelines, or the Focus guideline on LTS guidelines. And while these are not legally binding documents, states have incorporated these international guidelines into their own regulation and implemented as to this rule. Against the background of the recent increasing congestion in space, as you have heard from the previous speakers, we are seeing very interesting trends that states are coming up with more stringent or promising or ambitious space debris mitigation regulation and measures. For example, I think Max already mentioned FTC's introduction of 5 years rule, and European Space Agency have recently updated space debris mitigation technology requirements that includes a 5 years rule, while they're not the regulation, but apply to the ESA's missions. And also ESA have initiated so-called space zero debris charter, inviting industry as well, and co-develop concrete and measurable targets that needs to be achieved for space sustainability. And also industry has been working on developing voluntary best practices and guidelines. Space Safety Coalition, World Economic Forum has also recently developed the Space Debris Recommendation, and Paris Peace Forum has their space approach, and I think GISO also has voluntary guidelines. And I think commercial states, regulators, commercial companies, industry has been making efforts in terms of space debris mitigation, and I do have heard that some of the commercial solutions, including SSA or software, are also trying to help with all the stakeholders to have more, to conduct more, to contribute to space mitigation areas. Having said that, only mitigation is not enough. As you said, that growing number of space objects to be learned, and also already existing space debris in orbit. So space remediation or removal of space debris needs to go hand in hand with the remediation. And IADC has already kind of recommended to identify some technology concepts and technology that could be used for active space debris removal. And there are national and regional efforts to develop such a technology. I think, if I remember correctly, UK Space Agency has its own project, ESA, a Clean Space Project, and Japan JAXA has commercial commercial removal of debris demonstration program for CRD2. And now I'd like to talk about the CRD program, and this is the latest mission. And CRD2 program of JAXA is aimed at demonstrating technology to remove a large-scale debris from the orbit. And Astroscale Japan has been selected as a commercial partner for both phase 1 and phase 2 of the CRD program. And phase 1 mission involves with approaching, observing, inspecting, and flying around the Japanese upper space rocket body that is like 3 tons, 11 meters long, and located at 600 kilometers altitude. And this mission is currently being demonstrated right now. Our satellite called Agnes is currently somewhere in around 6 kilometers. And so far we have achieved to make approaches to 50 meters from the object rocket body. And JAXA has released the images of actual space debris taken from 50 meters away from the object. So if you're interested, please go to the JAXA's website and look for the CRD program. It's quite interesting. It's probably the first time for us to see actual space debris in orbit. So phase 1, it doesn't involve the removing part. It only makes close approaches and taking some images and information of the space debris, but it lays important groundwork for the phase 2 mission that involves capturing and removing the space debris from the cloud orbit. So we have recently awarded the contract and started developing the technology for actually capturing the space debris. So there are some developments recently, and I know there are still challenges when it comes to ADR. As Victoria mentioned, it is conducted contested space domain, and there is many speculation and reports on current space technology. There are issues of dual use implication for ADR, and also issue of some the legal issues and liabilities. And also technology itself still needs to be developed further. We have now we are trying to develop our technology to capture upper rocket stage body, but space debris, each debris has unique figures, and satellites have different figures. So it's not easy to come up with the technology that capture any kind of form of the object. So there are still many challenges, but states are working on, many countries are working on efforts, and mitigation efforts are going on. So hopefully that we will come up with a technical commercial solution, and that will work for everyone.
Thank you, and well done to Astroscale again on your resolution. Okay, so we're going to one more speaker talking about debris mitigation and using technologies for that purpose. So my last speaker here on my left is Mr. Sakthikumar from OrbitAID. So, OrbitAID, thank you.
Thank you so much, Dave, and first of all, congratulations for that Leo Labs and Astroscale achievements. And thank you for this opportunity for this panel. It's the last 2 to 3 years, just last year announced this kind of panel is only focused on drivers and models. This year is more focused on the procession. It's amazing. So, after that, I'm Sakthikumar, CEO of OrbitAID. We are doing this, we are doing the on-orbit services. That on-orbit service, part of that operation is refueling. So we are refueling for the satellite, which will extend the life of the satellite for many years. That's what we are targeting. And how we are going to contribute to the sustainability. Just wanted to combine, give it small glimpse about 2 or 3 ideas, and go for that others. So as you know that most of that man-made debris is almost 21,000, and in that actually 1 to 6 lakhs is almost 1 to 10 centimeter. You know that there is 1 to 6 lakhs of that 1 to 10 centimeter range of debris is mostly because of that left out fuel breakout in the space, or due to some chemical explosion or something. That will cause that increasing your debris and all this. Also, you can, if you are not removing the space debris also, still without launching also your debris is going to be increased. How it is actually, as according to this Leroux and Agnes is actually saying that it's a catastrophic effect is going to be there, that will increase your debris numbers. So for that actually, the satellite operators need to do more and more orbit corrections. Compared with 2015, they done the orbit correction to 3 firing. According to ISO, it's done the 3 firing orbit correction. 23 they done last year. So 2023 they done the orbit correction, especially for to avoid the stage conditions. They done for 23. So you can see that from 5 to 23 is. Further, you see, you have to have more propellant or more fuel consumptions. So this will increase your payload, this will increase your launch capacity. This will more and more problems in the future. And also, you can see that the way we are using that satellites, it is wrong. It is not wrong actually, but people or operators want to use that satellite in a different way. Where the Astroscale or other people want to remove the debris from one orbit to other orbit, they want to move it from one orbit to other orbit, they use the fuel. Again, that satellite operator want to capture that, they want to do the more encapsulation from one orbit to other orbit. Due to the fuel capacity, they are unable to use it. So they need to do, they want to do that for their sector field. And it is definitely, it is improve, it will increase their life also. For that, it is like which is very much important. And also coming to this, when ISRO recently this March, they removed the stage and actually from the last stage. They removed that from the orbit, and also they successfully done. Positive question. So they are saying they are climbing it actually 0 degrees things. The ISRO started, and other people also started. Where the standardization, Astroscale is introduced the base movable planes, where the standardization for it is like that the base movable plane, like that it's needed for standardization for on-orbit between clusters. That is what OrbitAID is providing. The standard, universal standard on-orbit docking between things, as well as we are providing that this refuelable propulsion system, which is actually, it's not meant to be explored in any case, in that if this level of fuel also is there, and that propellant has to be transferred efficiently and without carbon separation. We have to do that proper at the zero gravity transfer. So OrbitAID is providing that kind of propulsion system, and definitely we are using complete on services. So that we will do that complete tanker supply and more topic extended for many years for existing subjects also, as well as upcoming subjects also. And just one or two things that actually I want to mention is last year, July actually, AUS satellites from ESA, European satellites actually, we are getting QD fuel conditions. That is, but they want to increase that life, they want to do more operation. That is the one satellite is actually doing other orbit and done the power orbit, all the wind conditions, all those things they done. But they deviated because of that fuel conditions. Where they are also interested in the fuel refueling in orbit, but there is a standardization is limited. So OrbitAID is part of that, all the standardization is bringing that sustainable satellite to space to extend the life of the satellites.
Okay, thank you. And so we covered a lot of information there, a lot of different perspectives and contribution to the solving some of the issues of space sustainability. And impressively, everyone's kept to time, which has given us plenty of time for questions, which we're going to go to now. But I've given the first opportunity for a question to the future of space industry and space use. So we're very happy to join by Ben Cat. Leroux on Ben Cat. I met him 2 years ago at the first India Space Congress, and I told him he could ask the first question, and then at the end of the session, he's also going to provide his perspective, mark our homework in some respects. So Ben Cat, I'll come down to you a little bit, because I want to stand up, and you can ask a question of the panel or to any panelists. Oh, yeah.
Right, thank you, sir, for this opportunity. Thank you to SIA-INDIA for giving the opportunity to attend. So, I'll just brief out a small point / question. So, trace of Earth's atmosphere is basically visible. It decreases the higher we go, but it is almost visible in the gravitational influence of Earth. So, anyways, the lower we are in Leo, doesn't that mean that satellite itself and the debris can naturally just come down and re-enter Earth? So, that is where I will bring in my point. And can we basically regulate how high we keep our satellites so that we can make sure that they can enter naturally and don't need manual work? That's a question. Thank you.
That is a very good question. That is a wonderful question, so thank you. I would invite any panelists who want to speak about question, and then I'll talk about a few of our perspectives.
Thank you for your question. I appreciate your time here. Yeah, I mean, certain orbits are good for certain things, right? And there are different best practices in terms of what end of life is. It was mentioned in one of my film panels that the idea is to bring your satellite back down within 25 years now with SEC 5 years. But that's only low Earth orbit. If you're hired to geostationary orbit, the idea is to keep it up to a graveyard orbit about 3.5 kilometers north of that. A geostationary is at 36,000 kilometers. And so I think when we talk about looking at best practices becoming nationalized in the regulation, it's really up to each individual country to figure out how they want to carry out their responsibilities that they agree to various international guidelines. But I don't think it's necessarily helpful to say, okay, we're going to have one way in which to handle these sort of things for all tens of thousands of satellites, because it just simply depends on orbit regimes. And it's just not helpful to, for example, let's say you're a geostationary orbit and you want to bring it back down to burn Earth's orbit. Doesn't make Earth's atmosphere doesn't make sense because you're coming down tens of thousands of kilometers. So I think it just really depends on what the best practices are, but also I think, as I mentioned in my remarks, we need to rethink how we handle these things maybe, because maybe those best practices for what's good for orbital environment health is not necessarily what's the best practice for the Earth's atmosphere health. Terry, do you want to talk more about that?
Yeah, thank you. It's a very good point. So there's best practice, which some companies and regulators are enforcing, and there's some also good practice. But it's true. The lower you are, the less time you'll spend in orbit, especially in the 300 to 400 sort of kilometre area. It's only a few years. If you are an experimental type satellite, that's probably where we would prefer to see something which is experimental. So we'll do orbit in a few years after it's testing. And the higher you go, of course, the bigger the issue and the longer term. Now, one of the, I think, Maximilian talked about the 5-year rule from the FCC in the United States, going from 25 to 5 years. That's a big policy change for the US, and that's going to help some of the issues. But I think collectively we're saying that we'd like to see better practice and use regulators to reinforce best practice, considering these altitude regimes, so we don't end up accumulating all the space junk debris. So very good question back there. Thank you.
Just to add, actually that is a good point. So DARPA recently awarded a contract to a company. What they're doing is something called the VLEO satellite. Very low Earth orbit satellite, which will be around 200 to 50 kilometers. You know the problem, right? Satellite, if you keep it normally, with the drag, in few days it will come down. Okay, so currently you can't do that. But you want to do that, what you can do is, you need to, like the airplane you can have some kind of a engine where you can keep firing more often than currently what you need to do that. So for that, what people are doing is take air, which is oxygen molecule, and use it as a fuel. Use electric energy from solar panel, fuel from outside, like what happens, like sort of air breathing engines, what happens in the jet engine. You take it from. So that concept people are working on. It's a very novel concept because it has a lot more benefit. If you have to observe the Earth, you are much closer. So you can easily see a lot of details which you can't see at say maybe 500 kilometers. But it's something that you can, maybe once you grow up, or you can start immediately figuring out some studying, and that is a future problem. Thank you.
Thank you. Great question. Okay, so further questions? I'll go back up front. Thank you.
Hi, so we are a startup, and one of our focus area is collection of centimeter-sized debris, metal debris. So now my question is the confusion that we have on the business. So have you been to Farnborough Air Show and European Air Show and a discussion? And the question that I got from there is twofold. First of all, right now there is sufficient space so the industry is not bothered about debris collection, debris mitigation. And second point is where the buck ends. Is it the industry who is launching the satellites, or is the government who is going to pay for it? So who's going to pay for it? And that's why no, it's not moving in fast pace, this debt mitigation effort or collection effort. The money is not there yet, and when the market will mature. So, yeah, your views on that.
Okay, so 2 questions there. Would anyone like to answer either part of those questions? If not, yeah, so well, the second part of the question was the responsibility, whether it's on the commercial side or the government side, to basically regulate or operate effectively and responsibly. I think I'll answer that. What we're seeing at the moment, from our perspective, is these companies which are scaling, commercial companies like the Starlink system, like OneWeb, Planet Maxar, they are the ones that are actually driving best practice at the moment. They're the ones, for example, Starlink is deploying its new satellite constellation just above 200 kilometres. They do functional checks, make sure it's operational, and then they'll fly up into their orbits. Of course, if they're non-operational satellites, they pretty much deorbit within a month or 2. So, but that's not a regulation, that's good practice. That's one perspective. And then the regulators, I think, are a little bit reluctant in some respects to put too many controls on the industry at the moment because they want to see their industry successful. But regulators are starting to understand that they have responsibilities here. So we're starting to see some changes in regulations, if you like. So I'll leave it there. What's the first part of your question? You're more asking about the general type of problem set that we're dealing with. Did you want to reframe that at all? Or do you want to on commercial practice versus regulation?
Yeah, maybe I'll make a quick comment on it. Commercially, of course, as the debris removal, so nobody will do it voluntarily, it just adds costs to the emission. So you wouldn't say, let's do this unless it really helps to image it's like a branding thing that you say we are sustainable. I really think that requires a regulation, and it will in parts in the beginning bring up the cost, and there will be big companies lobbying against it that this is the end of the industry if you put this up. And you see this in every industry when there's regulations coming in. I remember growing up in Germany, styrofoam for disposable food container was being prohibited. And of course, companies like McDonald's and Burger King, they were all saying now nobody's going to take out hamburgers anymore. And they pushed it through anyways, and all of a sudden every burger was packed in a nice little paper. It was no big deal after all. So if we have a will to do something, we also need to face that we will be having lobbyists calling in, don't do this is going to be costly, but we have to weather the storm and do it, because we know it's the right thing to do and voluntarily, and I think people will put that on that bill of material.
Just building on that last topic, outer space treaty is pretty clear in this matter. Article 6 requires nation states to provide authorization and continuing supervision of their national actors, which means that when it comes down to it, nation states are responsible for the actors of their commercial companies, so they have an obligation to regulate them and provide this sort of things. The outer space treaty doesn't say how you're supposed to do it, just that you're supposed to do it. And so that's what we're seeing as more and more countries are getting involved in space. They're trying to sort out, well, how do we regulate these sort of things, and what are the best practices? Do we need to reinvent the wheel and these sort of things, or can we just figure out what country X does and we want to regulate that as well? But, and Terry's right, absolutely, the commercial sector has been leading the way of norms behavior. There's all sorts of, there's a space safety coalition. There is, the Confers Consortium for Execution Right of Servicing Operations. There's a Satellite Industry Association has their sustainability practices. There's all sorts of best practice documents by the industry. But I will also point out, when it comes right down to it, I believe space is a public good, and so you need to provide a certain basic level of space flight safety, and I believe that's up to the government to provide that. I will always point out that when commercial is allowed to regulate itself, on one hand they have an incentive to make sure the environment is stable and predictable. On the other hand, as Max pointed out, they want to do as little as possible with at least light regulatory touch. And when you allow commercial to regulate itself only, that's where you get things like fertilizer plants blowing up in Texas. So I think that is important to have the commercial sector working with the government, so you have all stakeholders involved in the conversation, so you have the best amount of regulations, so you have a stable space environment. Thank you.
Thank you, Victoria. I don't think we really answered your first question, but you might want to reframe it so we can get our heads around it a bit better. And we've got plenty of arms now, so I think I had a question from just behind the camera here. If you could go with that, please. Sorry, down the long wall.
My question is to Victoria and Aya. If countries come up with regulations for mandating heavy remediation and heavy mitigation measures, one of the concerns is that companies will just go to a country where regulations are not so stringent. So how do we strike a fair balance between a nation's interest in attracting investments in the sector and the need to achieve a sustainable space environment?
Okay, thank you. Good question. If it's more about regulation, it'll be very natural. And I think we just saw some good examples of that with the Astroscale issue. So would you like to talk about regulation and Astroscale? Because they're working with two agencies, with JAXA and with the New Zealand Space Agency. So two agencies involved in regulating the Astroscale mission.
It's actually a very tough question, but it's a very important question because even within the company, like I do policy, but our engineers have different modes of thinking because having a very stringent regulation actually creates a market for ourselves. But at the same time, it's not easy for engineers to come up with the designs and mission designs that is more stringent and more for space sustainability. So within the company, we also have discussion. What is the right balance? First, of course, the minimum requirements to comply with the existing regulations, like 25 years old. But how far can we go is the most important question. Whether we should aim at 5 years or 10 years for the mission. So I don't have an answer at this point. It's not an easy question, but having the discussion of each stakeholders making an effort to do what their best as they can is probably important. That comes out.
We were doing is to use lasers in space to find objects. Right? So at that point in time, United States has a regulation where you can't use lasers to dazzle other objects in the orbit. So one answer to this can be by restricting market access, and that's how the US does it. Let's say I'm an Indian company and as registered as an Indian object. If I provide this service to Indian, that's okay. But if it's to the US, they restrict the market access because I don't follow the regulation. I think that's one way to regulate and still maintain the guidelines.
Okay, thank you. So we've got some questions on this side now. Thanks, Ron. Ron, thank you.
It was nice panel discussion. I just want to know the current status, how International Space Agency is coming into a policy of decommissioning of any of the space missions. There is a stipulated time. So being a kind of space researcher, so I would like to have a more period of time where we can get data. But I see missions which is supposed to be had 5 years, but it goes for 15 years and it goes out of the control and becomes a space practice. So I just want to know if all the International Space Agency coming with a policy of decommissioning of any of these satellites with a stipulated time where the satellite is in control. So is there anything coming up with a common policy?
Okay, so thank you for that question. Would you like to leave your answer in that regard?
Yeah, so there is all the space agencies not come for the common policy, but where the common consortium is there actually. Where the common consortium is creating the policy and guidelines, which is actually taking care of that de-orbiting and all those things. And lots of initiatives like Zero Chatter, Zero Emission Chatter, other corpus things. That kind of consortium is there, where that is actually contributing to the regional policy. But I'm not sure we have it.
You know that IEDC diamond that is basically developed by space agency, they have 25 years for disposable time, but ESA recently updated this. Each space agency has technical requirements for their own mission, and ESA, I think, last year updated their requirements and reduced from 5 to 5 years. So I think there are several, as we said, that there's no common one, but there is definitely exists. So if you go look into each space agency's guidelines, you will find out what is the trend.
Maybe adding to that one, yeah, associated is actually where the ESA is actually announced that 20 years to come. Something then all people are also starting to accept that policies.
Okay, thank you. We're getting close to the end of the session. However, I wanted to offer the opportunity to now space Junior here at the end. So we'll take one more question from the floor, and then we're going to start to wind up. Yeah. I don't know where the microphone is. Just to remind over there. Here it comes.
Thank you for the opportunity. Anirudh, as a laser physicist by training, I'm sad to hear that we're finding lasers in space to tackle debris. Having said that, just wanted to understand if an arrangement such as Paris 2015 or ESG compliance for space should be brought in. What do you think? What are your thoughts?
So Paris 2015?
Yes. It's like
what we have for climate.
Yeah.
Oh, okay, yes.
Yeah,
Okay.
for space, absolutely.
So can we get international consensus for the management of space sustainability? We've only got a few minutes.
and one question about rather than putting the regulation to stop the debris, why not be incentivized like what we do for carbon credit? Can we do some incentivizing of removing that or the ensuring that the satellite doesn't become debris? So if you can do that at the government level, and then carbon credit you can trade, then the debris removal become the business case. So where the money comes from, the buyer was the partner. So this kind of arrangement can work. So like what carbon credit does. So carbon capturing and all those things. Similarly, like debris can become way too slow.
Victoria, this is right in your lane because as Q1 Foundation doing an important job here to try and build this consensus. That's what you're talking about. So.
Really quickly, so now we're at the end. It is actually possible for international consensus because we've already seen this happen. The United Nations spent the better part of a decade discussing long-term sustainability guidelines. The United Nations Committee on Peaceable Use of Cyberspace are hopeless. And after, again, almost a decade or two, so they came to consensus. When I say consensus, that means at that point, all 92 members of COPUS came to 100% agreement on 21 guidelines for long-term sustainability cyberspace. And so now what we need to do is see these things actually being carried out. So it is possible, and anyone can come to agreement, but we need to see national actors and stakeholders actually carrying out these guidelines.
Okay, very short answer. Possible, very difficult, I think. Okay, so we're not taking your questions. There is, well, the panelists, I think, are staying in the Congress for the next day or so, so please find your answer if you need one. So again, I'm going to step up and I'm going to put Venkat to try and mark our homework, see how we go, trying to address sustainability.
Okay, this has been a very interesting session. I really liked the panel and how they addressed the situation. I thank you to SIA-INDIA for allowing me to attend this, and thank you, Teddy, for giving me an opportunity to do this. So here we go. I'm Patnaik. I'm studying in grade 7, and I will be summarizing the session for today, as well as also giving you my thoughts over this task. So anyways, firstly, we had some major concerns addressed by the panel, which I'll go ahead and name. It was a big panel, so I hope I got the names correct. Dr. Agnes Chan, Mr. Maximilian Leroux, hope I got that right. And then there is right. Big panel, so got to remember the names. So yeah, Mr. Anirudh Sharma, then we got Ms. Victoria Samson, we got Mr. Tushar Jadhav, we got Ms. Iwamoto, hope I got that one right too, and Mr. Sakthikumar, and of course our respected chair and retired Commodore Haren. So let's begin with the summary. Firstly, we had some major concerns. We have too many constellations, which is one thing. We have Starlink, which is already big enough and is going to get bigger very soon. I think Elon Musk is launching a Starlink every month. And then we have got some multiple more constellations coming. Amazon's planning Kuiper, and then there is OneWeb who is also trying to build their constellations. That's 3 already. Then apart from constellations, we also have until now a lot less stringent and strict regulations. So basically, until say this decade, we didn't really care too much about their breed. Or too sensitive, so this is the reason why a lot of projects and constellations were approved. And lastly, we have, so that's all about early carelessness, and lastly, we have also got some very new projects, that is tracking. So just before the meeting, the discussion, Terry and I were talking about new satellite design, CubeSat in geostationary orbit. Now that is really good, and that is actually a really great initiative trying to dig down and make such satellites better. But at the same time, it is also to be noted that such satellites will be a bit difficult to track. So, yeah.
Can you give us a score? You're marking our homework. So just tell us, are we good? Are we going to get it right? Do we need to work harder?
Okay, so I'll give my thoughts really quick. So I guess we are doing great. This whole panel has a lot of initiatives and a lot of tracking. But the amount of debris we have, I guess we also have to work harder. And I guess work harder forever, because once we solve this problem, we just have to make sure it never happens again. So that is what I really think about. And at the same time, we should also try new satellites. Some people OrbitAID is trying. So yeah, that is good and short way of saying, let's keep this going.
We're out of time.
Right.
Thank you very much, Venkat, and thank you very much to the entire panel. It's been indeed very insightful, and I think everybody will hook to their chair so nobody will get up. With this, we come to the end of this session, and we'll go ahead with the felicitation ceremony. May I request the chair, Recommended Terry Van, to kindly felicitate the co-panelists. We'll start with Ms. Victoria Samson. Can you have more questions? Mr. Tushar. Iwamoto. Mr. Sakthikumar R. Mr. Anirudh Sharma. Mr. Maximilian Leroux. And Dr. Agnes. We call upon Shri Jadhav, Senior Director, SIA-INDIA, to kindly felicitate the Chair, Air Commodore Haren. And you can have a big picture. All of you together. Thank you very much. We have one big group picture, all of you together.
You want us in front of the table? Where is the table? Please, sir. Excuse me, sir. Thank you.
Thank you very much. Once again, all the gentlemen and the ladies for this highly enriching discussion. And it's time for a networking tea.